Welcome to the Explainer. Today, we're talking about Apache Cassandra, a database that was basically forged in the fires of web scale. It's built for one thing, really, absolutely mind-boggling scale.
All right, let's jump right in. But, we're not going to start with the tech itself. We're going to start with the problem it was built to solve. And I'm talking about a problem of just unimaginable size. Imagine needing a system that can handle billions, with a B, billions of writes a day and not even flinch. That's the challenge we're talking about. So let's rewind the clock to 2007. The place? Facebook. Their engineers were in a real bind. They had this huge project, building the inbox search feature. The problem was, the scale they were dealing with was something totally new, something they've never seen before. I mean, just look at these numbers. The growth was insane. From 100 million users to 250 million in just 1 year. Their old school databases, the traditional master-slave setups, they just couldn't handle it. They were crumbling under the sheer weight of all those writes. They needed something new, and they needed it yesterday.
So what do you do? Well, the engineers, Avinash Lakshman and Prashant Malik, did something really smart. They didn't try to reinvent the wheel. Instead, they took the best ideas from two of the biggest players in the game, Google and Amazon, and fused them together to create Cassandra.
And this combination is really the secret sauce. It's Cassandra's DNA. From Amazon's Dynamo, it got its backbone, its architecture, this peer-to-peer no master node design where every node is an equal. That's where its famous always-on availability comes from. Then from Google's Bigtable, it got its data model, the super flexible wide column thing that's just built for ridiculously fast writes. So the easiest way to think about it is it acts like Dynamo on the outside, at the cluster level, but on the inside, how it stores data, it's all Bigtable. Okay, so this hybrid design brings us to what really makes Cassandra, well, Cassandra. It's that masterless architecture. This is the key to unlocking all its power, both for scale and for never going down.
So think about how most databases used to work, and many still do. They have this master-slave setup, right? Every single write has to go through that one master node. And what happens if that master node goes down? The whole system can grind to a halt, or at best, you can only read data. It's a massive bottleneck and a huge single point of failure. Cassandra's solution? Just get rid of the master altogether.
Poof, gone. There is no master node. Every node in the cluster is a peer. They're all the same. Any one of them can handle any request for any data at any time. It's a total game changer.
But wait, you might be asking, how do they all stay in sync without a boss? Well, they form this logical ring, and they talk to each other. It's literally called a gossip protocol. Just imagine all the nodes constantly chattering, sharing the latest news about who's up, who's down, what the load looks like. It's this constant communication that makes the cluster so resilient. If one node suddenly disappears, everyone else in the ring already knows about it and can just work around it. No panic, no downtime.
Now, this kind of architecture, it forces you to completely flip your thinking, especially if you're used to the SQL world. You can't just take your old habits and apply them here. You really have to turn your entire data modeling approach upside down.
Here's the fundamental difference, right? In the SQL world, you'd create these nice, clean, normalized tables to avoid repeating data. Then, when you need to answer a question, you use joins to stitch everything together. In Cassandra, it's the exact opposite. You start with the questions your app is going to ask. You think about your questions first. Then you build tables specifically designed to answer those questions, and only those questions, as fast as possible. And yeah, that means you'll repeat data all over the place. You denormalize on purpose, because the biggest rule in Cassandra is no joins.
Okay, so to make this whole query-first thing actually work, you have to get your head around the single most important concept in Cassandra, the primary key. And listen, it's not just some unique ID for a row. It's much more than that. It's basically the physical address for your data. It tells Cassandra exactly where to find it in this giant cluster. The first piece of that primary key is the partition key. Think of this as the street address for your data. Cassandra looks at this key, does a quick calculation, and knows exactly which node in that big ring holds the data you're looking for. So instead of searching everywhere, it goes straight to the right spot. Super, super fast. Then there's the second part, which is optional, the clustering columns. Now, if the partition key is the street address that gets you to the right house, the clustering columns tell you how the files are organized inside the filing cabinet in that house.
It dictates how the data is physically sorted on the disk. And this is amazing for queries like, hey, give me the last 10 comments on this post. It's incredibly efficient because the data is already in order.
All right, so this whole model is built on one of Cassandra's superpowers, its ability to just swallow a ridiculous number of writes. And it's not magic. The secret is a really clever, optimized process that avoids the absolute slowest thing a database can do, randomly searching for stuff on a spinning disk.
So check this out. A typical database, when you update something, has to go find the data on the disk, read it, change it, and write it back. It's a lot of work. Cassandra, it doesn't do that. It just appends. A new write comes in, it gets slapped onto the end of a log file on disk. That's for safety. At the same time, it's written into memory, into something called a mem table. And then, this is the key part, it immediately tells the client, yep, got it, we're good. The data hasn't even been fully processed and stored in its final resting place. But as far as the application is concerned, the write is done. It is all about insane speed.
So you put it all together, this masterless design for huge scale, the always-on availability, and these crazy fast writes, and it's no surprise that Cassandra is the engine behind some of the absolute biggest apps on the planet.
In fact, I'd bet you've used Cassandra multiple times today and had no idea. That movie Netflix just recommended to you, the playlist Spotify built for your workout, the endless feed of photos on Instagram. Yep, behind the scenes, that's often Cassandra, just humming along, making it all happen. So where does it really shine? Well, it's perfect for any situation where you have just mountains of data, a ton of writes coming in all the time, and you absolutely positively cannot go down. We're talking about things like data from millions of IoT devices, huge messaging apps, or those personalization engines that track every single click you make.
So here's the bottom line. Cassandra makes you think differently, for sure. You give up some of that ask any question flexibility you get with SQL, but what you get in return is almost infinite scale and rock-solid resilience. For the right kind of problem, the really big, fast global ones, there's just nothing else like it. And that kind of power really gets you thinking, what seemingly impossible problem could you go out and solve with a tool like this?